Hey there, and welcome. Today, we are going to pull back the curtain on the Arduino. You know, if you've ever written a line of code, you know it kind of just lives inside your computer. But what if? What if you could make that code reach out and actually do something in the real world? Well, that's exactly what this little board is all about. Seriously, have you ever been coding something and just wished it could do more than push pixels around on a screen? Maybe you had an idea for a gadget that waters your plants, or a little robot, or something that changes based on the light in your room. That gap between your digital idea and a physical thing can feel, well, pretty huge. Well, guess what? The Arduino is that bridge. It's the missing link, the connection point between the logic on your computer and the lights, motors, and sensors of the physical world. So let's figure out how this bridge actually works. Okay, so before you can build anything, you've got to know your tools, right? We're going to start with a quick tour of the board itself, the anatomy of the Arduino. Let's break down what each of these key parts actually does. Now, the whole thing is called an Arduino, but its true brain is this big black chip right in the middle, the microcontroller, or MCU. Now, don't confuse this with the processor in your computer that's juggling a dozen apps and an operating system. No, the MCU is a specialist. It has one job, and one job only, to run your code over and over again in a simple, endless loop. It's totally focused. So how do we get our instructions to that specialist? That's where this little guy comes in, the USB to serial chip. See, your computer speaks the language of USB, but the microcontroller speaks a much simpler language called serial. This chip is the essential translator. It's what lets your code travel from your keyboard through the USB cable and right into the brain of the board. All right, this next one might be the most important pin on the entire board, ground, or GND. You have to think of electricity like a loop. It has to flow from a source, do its work, like lighting up an LED, and then it has to have a path to get back home. Ground is that return path. Without it, the circuit's broken, and nothing, absolutely nothing, will happen. And this quote just says it all, doesn't it? If you forget to connect your ground pin, your project is dead in the water. It's not a circuit, it's just a bunch of parts sitting there. Seriously, it's the very first thing you should check when something isn't working. It is non-negotiable. So we have a brain, and we know how to talk to it. But how does the Arduino actually sense the world and take action? Well, that's where its input and output pins come into play. Let's dive into how it uses these to interact with everything around it. The Arduino basically has two ways of seeing the world, digital and analog. Digital is super simple. Think of it like a light switch. It's either on, which we call high, or it's off, which we call low. That's it. Perfect for a button press or just turning on a light. But analog pins, they're more like a dimmer switch. They can read a whole range of values, like how bright a room is or how far you've turned a knob. But here's where it gets really clever. Some of the digital pins have this little squiggly line, a tilde next to them. That's a secret superpower. It means they can do something called pulse width modulation, or PWM. Basically, by turning on and off incredibly fast, these pins can fake an analog signal. It's how you can do things like dim an LED or control a motor speed using a pin that's technically just digital. It's awesome. And on the flip side, the analog pins have their own special hardware, an analog to digital converter. This thing literally listens to a real-world voltage, that smooth, continuous signal from something like a temperature sensor, and it translates it into a number, specifically a number between 0 and 1023, that the digital brain, the MCU, can actually work with. Okay, enough with the theory. The absolute best way to learn this stuff is by doing it. So right now, we're going to get our first two big wins. And the best part? We're going to do it without writing a single line of code. This is all about getting your hands dirty and building some confidence. First up, let's just check for a pulse. Grab your USB cable, plug one end into the Arduino and the other into your computer. You should immediately see a little green light turn on, usually labeled on or PWR. That's its heartbeat. It's alive. Then just open up the Arduino software, go to Tools, and tell it two simple things. Hey, I'm using an Arduino Uno, and it's plugged into this port. That's it. You've made the connection. Now for win number 2, your very first circuit. We're just going to use the Arduino as a simple battery for now. Connect its 5V and ground pins over to a breadboard. Then pop in an LED. Just remember, the long leg, the anode, goes towards the 5V power, and the short leg, the cathode, goes towards ground. But make sure you put a resistor in its path. As soon as you complete that circuit, boom, the LED lights up. You just built something that works. Now hold on a second. Let's talk about that resistor.
It's super important, and here's why. Each of the Arduino's pins can only handle a small amount of electricity, around 20 to 40 milliamps. If you try to pull more than that, you will literally fry the pin and release what we call the magic smoke. And trust me, once the magic smoke is out, you can't put it back in.
Awesome. You've powered up the board, you've built a circuit, you're doing it. Now let's zoom out a little bit. We'll see how this board, the Uno, fits into a bigger family, and I'll give you a huge tip to avoid one of the most common beginner headaches. So the Uno is the undisputed champion for learning and prototyping. It's perfect, but it's not the only one. If you're building, say, a giant robot with tons of sensors and motors, you're going to need the Arduino Mega. It's the heavyweight with a crazy number of pins. And then, once you've perfected your idea and you want to make it small and permanent, you'd grab a Nano. It's all about picking the right tool for the job you have in mind. And please remember this pro tip. It will save you so much time. See those first two pins, pin 0 and pin 1? They're actually sharing the same communication line as your USB port. So if you have anything connected to them when you try to upload new code, it's like a traffic jam. The signals collide and your upload will fail every single time. So the rule is, always unplug anything from pins 0 and 1 before you hit upload. And that's it. You know the key parts of the board. You know how it senses and how it acts. You've already built a working circuit with your own two hands. You are literally holding the bridge between your imagination and reality. So the only question left is, what are you going to create?